Let's look at the next one about x equal to 2. So this is a little bit harder. So there's a 2 over here. Axis of rotation is x equal to 2. So oh shoot. Like so. X equal to 2. All right, cool. Step 1, chop up parallel to the axis of rotation. Step 2, dx or dy. What do you think? Dx is correct. Axis of rotation. Step 2, dx or dy. Is there anyone that can't tell that it's dx? I'm trying to think of this as a little bit of thickness right there, and it lies on the x-axis. That's why it's dx. Step 3, you gotta set it up. Put the dx over here. You gotta look at this yellow shaded region and ask yourself, what's the smallest x could be and what's the biggest x could be? What are the limits of integration gonna be, my friends? 0 to 1 is correct. Let's do the easy part first. What's the height of your function going to be? The height of the cylinder. Rad x is right. I'm going to put it to the 1/2 power. Here's the hard part. We want to know what the radius is going to be. So if I shade in this region right here, the radius should be the distance from here to here. Keep in mind, this is an x value. Terry, I can never get you to message the whole class, right? You're only going to message me privately the whole time. I give up. It's not 1. 1 is the distance from here to here. I want the distance from here to here. We got x minus 1, x plus 1. The distance from here to here is x. The distance from here to here is 1. I think it's definitely not x plus 1. It's definitely not x minus 1. It's definitely not x times 1. No, none of these are right. You want to take this total distance from here to here. That total distance is 2. And you want to subtract away the distance from here, which is x. So you want to subtract those 2 because this distance from here to here is what my radius is going to be. So if this whole distance is 2, and this distance is x, what's this radius going to be? That's going to be 2 minus x. I don't know how to make it more obvious. Maybe x plus r is equal to 2, right? This distance plus this distance is equal to 2. So this means that r is equal to 2 minus x. That's one way you can think of it. Another way you can think of it is you can take the right function minus the left function. The right function is 2. The left function is x. So then your radius is 2 minus x. All right, Ian, good. We'll have 2 more examples, so then you can see even better. This case is the hardest case. I'm not going to lie. So for sure. About y equal to -3. So y equal to -3 is a horizontal line. So here's -1, here's -2, here's -3. So y equal to -3 looks like this. Let's do this. Step 1, chop up parallel to axis of rotation. This time we got horizontal lines. Step 2, dx or dy. Which one is this guy, dx or dy? Dy is correct. Now look at your shaded region. What's the smallest y could be and what's the biggest y could be? What are the limits of integration? Zero to 1. I agree. We're going to put a 2 pi, we're going to put an r, and we're going to put an h here. So do you remember how before I had this labeled as x equal, y equal to x to the 1/2? Because it's a dy thing, I want y to be the independent variable. So how can I turn this guy into something that depends on y? How do I rewrite this equation so that y is the independent variable? So I want this to be x equal to something. X equal to y squared is correct, Sharon. So I got x equal to y squared. That's this line right here. Oh, that must be Jasper. Jasper, do you have spectrum? Don't answer that. First question, what's the height going to be? With the height. What if I told you that y squared is the distance from here to here? Would that change your answer? I want the distance from here to here. 1 minus y squared is correct. How can I see that? I do the right function minus the left function. The right function is x equal to 1. The left function is x equal to what? Y squared. That's how you get 1 minus y squared. That makes sense? Let's find r. R is going to be, if this is my sort of typical shell, r is going to be the distance from here to here. Any thoughts as to what this is going to be? Top minus bottom is correct. Y minus -3 is correct. Y plus 3 is correct. So this guy is y plus 3. I'm going to write down what Ken said. This is top minus bottom. Remember, oh shoot, I got a meeting. The distance from here to here is y. Remember, y is bouncing between this whole shaded region, starting at 0 and going to 1. That's what this dy going from 0 to 1 means. So the top function is definitely y. The bottom function is -3, right? I forgot to label that. This is y equal to -3. So when you do y minus -3, you get y plus 3. Go away. So then in the end, your integral is going to be the integral from 0 to 1, 2 pi y plus 3 times 1 minus y squared dy. So to integrate this, you got to multiply it all out and integrate. So when I say multiply it all out, I mean got a foil. See, I distribute. Does that make sense?